So the image formed by a convex lens, depending on the position of object as well as the focal length. So example, if an object is placed after 2f or beyond 2f, how to draw an image? First, you will draw a parallel light ray. So when there is a parallel light ray, from where it will pass through focus. And one through the optical center, it will pass straight. So when these two light rays will pass, they will converge at one point. The point where they will meet, that is the position of image. So when you can continue the rays, but the point where the two light rays meet or intersect, that is the position of image. So you can clearly see this is an inverted image or upside down. It is a real image. It can be seen on screen, and it is also a very small image or diminished. So real, diminished, or an upside down. So when we change the position of object, the position of image will also change. Like if the object is at 2f, first the parallel light ray will pass through the focus, one through the center of the lens will pass straight, and the two light rays will meet or intersect. And when we compare here the size of image with size of object, it is a real image. Why we called it is a real image? Because it is formed by intersection of the two lines. So that's why it is a real image. It is inverted upside down because object is pointing up, image is pointing down. And it is same size. Object and image have the same size. Like if object is 2 centimeter, image will also be 2 centimeter. So there are fixed positions. If object is after 2f, as you can see in the previous one, when the object was after 2f, where the image is forming between f and 2f. But if the object is at 2f, where the image will form at 2f. But if the object is between f and 2f, like object is closer to the lens, so parallel light ray, it will pass through the focus, one through the center, will pass straight. So you can see here that when these two light rays will intersect, they will intersect at a point, they will converge at a point, and this point, what will happen? The image will form. So when the object is between f and 2f, where the image is formed, it is formed after 2f. It is a real image because it is formed by intersection of the lines. It is large or magnified image, and it is also upside down. So if object is a triangle, image will be a triangle, but it will be a large triangle as it is larger in size. So when we move the object towards the lens, the image will form away from the lens and the size of the image will increase. Now example, if we say this, you should draw at the same time. The way I'm solving, you should draw at the same time. Like example, if we say draw an image formed by the convex lens of focal length 3 centimeter when object is placed four centimeter from the lens. So first what we do, whenever this question is there, we'll always draw a horizontal line. That's a principal axis. Then on the principal axis, mark the position of the lens and draw the dotted line. That is the position of the lens. Now, according to question, we have to draw an image formed by a convex lens which is having a focal length of 3 centimeter. So what we have to do, we have to measure 3 centimeter and mark F and further 3 centimeter or total 6 centimeter, mark to F. And same thing you will do on the other side, mark F, 3 centimeter, mark F, and further 3 centimeter, mark to F. First do this. F should be 3 centimeter and 2F should be 6 centimeter. Everyone should complete till this point. So now after marking F and 2F, the object is placed 4 centimeters. So object can be anywhere. It's not necessary on the right hand side or left hand side. It can be anywhere if they do not mention. So measure 4 centimeters. So definitely 4 centimeter will be after focus, and draw an object and label that as O. Everyone should do this part. No, this not this height. This height can be any. Like it's not the 4 centimeter is not the height of the object, it is a distance from the lens. Object can be small, object cannot be small larger than the lens, so you should draw a smaller object compared to lens, but that position is 4 centimeter from the lens. You are done till this point, and label that as O, the object. Now draw the light rays. Yeah, draw the light ray. First one parallel to principal axis. So if it is parallel to principal axis, from where it should pass? It should always pass through focus. Draw the first ray of light parallel to principal axis. It will pass through the focus. Complete this one. Parallel light ray is passing through the focus. Then one which is through the center of the lens will pass straight. Continue them. On my figure, they might not intersect because I did not measure them. Just a minute, I will. Example, this was F and this is 2F. So parallel light ray will pass through the focus. One through the center of the lens will pass straight. The point where these two light rays will meet, that is the position where the image is formed. So draw again from tip of the object, draw a line through the center of the lens, and that line should pass straight, because one which is passing through the center of the lens, without any deviation, it will pass straight. So when these two light rays will combine, that is the position where the image is formed. So when we draw this image, how it will appear, this image will appear as virtual or imaginary. Like it is in reality, it is not there, it only appear, it is formed. So whenever the object is placed after F, the image will be real. But some cases the image won't be real image, it will be a virtual image. In this case, it is all the cases a real image. So drawing an image formed by the convex lens as magnifying glass. All the previous images were real images, but how an image can be a virtual image, for example, imaginary line, which is passing through the center of the lens, that is principal axis, and this is the position of the lens. Then we have f focus and 2f, and we have f and 2f. What if the object is placed between f and 2f, like object is placed here? So if object is placed between f and 2f, what will happen? The two light rays, first one, the parallel light ray, it will pass through the focus. The second one will pass through the center of the lens, it will pass straight. So these two light rays will never intersect. Why they will not intersect? Because the distance between the two light rays is continue to increase. It is increasing continuously. So if the two light rays, the distance between the two light rays will continue to increase, what will happen? They will never meet. So how the image can be formed in this case? So when we are looking from this side, our brain sense that the light is coming straight from the object. So when we are looking from this side, this is just our imagination that light is coming straight from the object. So when we produce these light rays, so when we are producing these light rays, as these light rays we produce them backward, this is the position where the image is formed. So in reality it is not there, this is just our imagination. And here what happen, if object is a triangle, image will be a triangle, but it will be enlarged triangle or magnified triangle. So this image which is formed is not the real image, it is virtual image, it is just imagination. So whenever object is placed anywhere between the focus and the lens, the image formed by a convex lens is always a virtual image. So if object is, so the position of the object is very important. Like if this is a lens, so this is a lens, the object f is there and 2f, and then there is f and 2f. So object is placed anywhere. Like example, if we place anywhere the object till this point, so what will happen? This will produce a real image which can be seen on screen. But if object is within the focus and the lens anywhere, so this will produce virtual image. So as you can see in the previous examples, the image formed by the lens. So without completing the diagram, we can identify the nature of the image, whether it is real or virtual. As you can see, like the object is placed here after 2f. So if the object is placed in this region, this whole region, the image will be real. So whenever object is placed anywhere after the focus, the image will be real. So here what happened, the parallel light rays, when it is passing through, it will pass straight, and one through the center of the lens. The two light rays will intersect. When the two light rays will intersect, the image will be a real image. Same way, if object is placed at f, Again, it is in the region of the real image. So when the two light rays will pass, they will intersect and it will result in a formation of real image. Object, again, it is after 2 after F. So again, the result will be a real image. But what about virtual image? If an object is placed between the focus and the lens, so first the parallel light ray, it will pass straight, one through the center of the lens. First the parallel light ray, it will pass through the focus, and one through the center of the lens will pass straight. So these two light rays will never intersect. So as they will never intersect, when we are looking from here, our brain sense that the light is coming straight from the object. So when it produces it backward, the position where it will intersect, because of our imagination, we call that as virtual image. So whenever object is placed between the focus and the lens, the image will be virtual. But if it is after the focus, the image will be real. Is it clear? Now some questions related to this topic about the lens. So the exercise related to light. Today we'll do some lens question. As you can see here, the diagram shows a converging lens forming an image. So this is a virtual image. How we identify it's a virtual image? Because first the parallel light ray, it will pass through the focus. One through the center of the lens will pass straight. So two light rays will not intersect. So when our brain create an image or imagine, this image will be virtual. And virtual image cannot be seen or taken on the screen. So which eye can see this? The eye, because this is imagination. It in reality nothing is there. This is the imagination of I Y. This I at Y is imagine that the light is coming straight, and this imagination is there which is producing the image. So this is imaginary image which is produced by Y. So for example, if I imagine anything, you are not able to see my imagination. So what will happen? IX cannot see this imaginary image or virtual image. It is only the imagination of Y. So it is a virtual image and it can be seen by Y, because this is the imagination of Y, not X. Is it clear? Discussion? Look what happened. If we have, this is the principal axis. Here is a lens. Focus is there, 2F is there, and F is there, and 2F. This is the object. Now the parallel light rays. Parallel light ray will pass through the focus. One through the center of the lens will pass straight. So these two light rays will never intersect because the distance between them is increasing. So they will never intersect. So the person who is looking from the side, a person who is looking from this side, when he receives these light rays, his brain will imagine or create an imagination and produce these light rays backward. So when the brain create the imagination or produce the imagination backward, this is a position where the image is formed. So this image will be seen by person at A. But if there is another person at B, he won't be able to see anything. Why? Because this is just an imagination. In reality, it is not there. This is imaginary image, a virtual image which is created by A. So that's why B is not able to see this virtual image. Same thing happened in the question. As you can see, this is the imagination of imaginary image produced by which eye? X or Y? Which eye imagine that there is an image. So when the light ray is passing through the lens, when we are looking from the other sides of our imagination produce, so this is the imagination of Y. Y imagine that the light is coming straight and produce an image. So if this is imagination of Y, the X is not able to see this imagination. That's why D is the right answer. Is it clear? So image formed by a plane mirror. What happened in a plane mirror? How the image is formed? Like example, if this is a plane mirror which is having one side polished and one side is rough. So there is an object. The two light rays which strike the mirror reflected. So when the two light rays which strike the mirror and reflected or bounce back, when a person is looking inside the mirror, these two light rays, again imagination is there. Like our brain sense the light is coming straight, as the two light rays does not intersect, so our brain sense it is coming straight and it produces them backward. So what kind of image is there? Because this is just our imagination. So what kind of image is there by a plane mirror? That is virtual. And magnifying glass, the same thing what happened in a magnifying glass. This is a case for a magnifying glass. When object is placed between the focus and the lens, the parallel light ray passes through the focus, one through the center of lens pass straight, and the imagination is there. This is again imagination. Our brain sense light is coming straight from the object and it produce an image. So this image is also a virtual image. So whenever you have a plane mirror or you have a magnifying glass, the image is always virtual. That's why D is the right answer. Is it clear? The magnifying glass means which is used to enlarge the object. Question 14. The student draw a diagram representing the three rays from point P passing through a converging lens. Each point label F is a principal focus. Which ray student draw correctly? So how we know student draw correctly? Number one, if it is parallel. So from where it should pass through focus. So it means ray X is correct. The second one, if it is passing through the center of the lens, it should pass straight. So ray Z is also correct. What about the third one? If it is passing parallel, sorry, if it is passing through the focus, it should go parallel. But what happened? For ray Y, it is not going parallel, it is converging again to focus, so ray Y is incorrect. So X and Z are the correct rays. An object is placed in front of a lens. The lens has a focal length f. The lens produces a real and enlarged image. Real image. So where we should place an object to get a real image? Look, if we place object here, it will be a virtual image. This will produce virtual image. If we place an object after focus, it will be a real image. So both A and B will produce real image, but it should be enlarged as well. Like its size should be larger. Enlarge image of object, like the size of image should be larger. So if you want a greater size of image, the object should be closer to the lens, because when object is closer to lens, like how the image will be formed, if it will, B is the right answer, because when parallel light ray, it will pass through focus and one through the center of the lens will pass straight. So the point where the two light rays will intersect, that is the position where the image will form. So this will result in a formation of enlarged image. So B is the right answer for this question. C and D, what it will produce? It will produce a virtual image. But in the question, what we need a real and enlarged image. So real image is only formed when the object is after the focus. In this question, question 19, a thin converging lens is formed an image. What is the nature of image and can it be formed on screen? Look, first parallel light ray passes through focus, one through the center will pass straight and they intersect. So when they intersect, they combine and image is formed. So this is a real image. When light intersect by itself, it is a real image. So this image is a real. And whenever we have a real image, it can be taken or seen on the screen. So real images can be seen on screen. Virtual images cannot be seen or taken on screen. Is it clear? Question. So this was topic light. Next session we'll do more questions related to lens. First I will revise this lens again and then we'll do more questions from this topic.